of Go began at Google in 2007, and the first stable release was in 2012, so it's a relatively young programming language. The Go designers were looking for something very small and simple to learn, and so they did not include a lot of things in the standard library. So we'll see here that the container directory only has 3 different containers that are provided by the standard library. So we already saw maps and we saw slices. In the container directory, they add heaps, lists, and rings. And we'll go ahead and take a look at lists. So list is a doubly linked list. And you'll note here in the definition of the doubly linked list, we have this type any. And so any allows me to put basically any type at all into the list. So what this means is that a list in Go could contain things of different types. So you could have your first element as a string, and your second element is a struct, and your third element is an integer. And so generics are a feature whereby we can actually create a type and specify that a particular type is associated with it. So in order to demonstrate that, I've created a sorted linked list package that will be a generic. In the generic syntax, you'll see here is these square brackets. So when I create a variable of type node, I can't just say node, I have to say what kind of node it is, and in particular, what type will be associated with that node type. So I can put here, you see there's a constraint, so I'm allowed with cmp.Ordered to put integers, floats, and strings. These are the basic ordered types in Go. So with this package, I'd be able to create a sorted linked list of integers, floats, strings, but not of structs or booleans or anything else. Here is a simple method for insert. So you'll see what it does is it creates a new node of the data type and the value, and then if it's smaller than the head of the list or there is nothing in the list, then it will put it at the head. Otherwise, it loops until it finds where it belongs in the list and then inserts it at the appropriate place. Remove looks very similar. Again, you see that type parameter. If we don't have anything in the list, we return false. If we're the first thing, we simply remove that and return true. Otherwise, we loop until we find it. And we make sure that current stays 1 behind the thing we're trying to remove, so we can simply make current next point around the thing we're trying to remove to current.next.next. Since Go is garbage collected, I don't need to worry about trying to free or delete or anything like that the node. And I'm also adding a little stringer method here that's going to return a string representation of the list. And this implements an interface so you can just pass a pointer to a list to printf, and then it will print it out. So this prints each value with an arrow pointing to the next one. I have a very tiny demo program that will create a linked list of, as you see here, integers. It inserts 20 and 10, and then we'll print that out. So if I say go build generic sorted list, and as you would expect, 10, 20, and nil. I've also included a little test package here. This test will in fact cover 100% of the statements using the table-driven testing with Testify. So again, we're going to create a list with a 10. We'll insert 30, 10, and 20, 20, 10, and 20, 20, 30, and 10, etc. And so you'll see here, here's sort of the key for generics. When we create a sorted linked list, we have to say what is a sorted linked list of, and so it's a sorted linked list of integers. So the nice thing about generics is it's going to enforce type safety. We're going to know that everything in the list is of type int with the built-in container. When I pull something out of the list, I have to cast it to the type that I want it to be, and that could generate an error if I've in fact mixed the things that I've put in the list. And so here are some more test case for removing. Right, so we're trying to remove from an empty list, removing 42, removing from the beginning, removing from the middle, removing from the end, removing something that's not there, all the way getting past the end to see that it's not there, removing the first one of the duplicate, so you'll see that one of the 20s will remain. And again, we have the table-driven testing with the t.run. We could add the t.parallel if we wanted these tests to run in parallel. All right, and that's a brief introduction to generics, and hopefully you'll find them helpful.